they are the lowermost part of the well, and normally it is provided in uh, well foundation, and it is the part which cuts through the earth initially. So there are certain basic properties which are required for the cutting edges. The first thing is that it should be strong enough, because it may be possible that at the bed level so many obstructions might be there. So if it is not strong, then it may not be possible to resist the different stresses during sinking. So first and foremost important thing is that it should be strong. Second, it should capable of preventing sudden sinking if soft stratum met with. અગર એકદમ સોફ્ટ સોઇલ આવી જાય તો ફટાફટ એના અંદર જો સિંક થવા માંડે, so it may be possible that due to unequal layer of soil, one part that may sink more and other part will sink less. So if sudden sinking, it should not be there. Then airtight. Generally, this airtightness is very essential in case of pneumatic caisson, because pneumatic caisson we want to avoid air and water inside your caisson, because workers are working inside. Then edge should be well protected by steel point. Normally, this edges that are generally provided with the steel angles. So these steel points are to be provided just to avoid the damage to edges. अगर આપણે સ્ટીલના પોઈન્ટ ના પ્રોવાઈડ કરીએ તો ત્યાં ડેમેજ થવાના ચાન્સ છે. સો પ્રોપર પ્રોટેક્શન ઇઝ ટુ બી પ્રોવાઇડેડ એટ ધ એજીસ ઇન ધ ફોર્મ ઓફ સ્ટીલ પોઈન્ટ. સો હિયર યુ કેન સી. Then outer edge should be vertical. So generally we want that this caisson, they should exactly sink in vertical direction without eccentricity. So that is very essential that it should be vertical. Then inclined angle, this inclined angle, you can see this is the inclined angle which is provided. It depends upon type of soil. If very hard soil is there, it should be small. So this angle of inclination, depending upon the soil, you have to choose what exact with the horizontal you have to provide. Then reinforcing bars, they should be provided between the cutting edges and the wall, because ultimately this cutting edge is about that there is a curved portion, then staining portion. Already we have learned this in well foundation. Okay, so proper bonding is to be there. Then if a water jet is used, if a certain time the friction is too much, then along with the cutting edges, the water nozzles that are provided. So these water nozzles that can be accommodated in the cutting edge के अंदर इसको accommodate कर देना है, so that it will reduce the skin friction. Okay, so these are some of the basic requirements that is required for any cutting edge. Now there are two types of cutting edges. So first cutting edge, it is with the sharp end. So here you can see it is the sharp edge which is provided at the bottom. So this is very sharp, and here you can see the base. Here this base is not that much sharp, but it is the flat base. So that is called as blunt end. So there are two possibilities of cutting edges with the bottom end. First is sharp end and second is blunt end. So we'll discuss both in detail now. This cutting edge is with the sharp end. So here in figure you can see this plate at the bottom, all are very sharp. Okay, and that exactly going to strike on the soil. So basically these are all the cutting edges with the sharp end. So here if this is the case, this kind of steel angle, the sizes etc are given. So it is used for the open cylinder type of the means it is used for the open caisson, you can say open steel cylinders, that is well foundation. Then this type of arrangement, somewhat flat edge is provided, then again inclination is provided. It can be used for the caisson to be sunk through the sandy soil है, तो उसमें से normally इस type का cutting edge use कर सकते, but all are with the sharp end. And here this is used for the soft soil and also for the pneumatic caisson, this kind of arrangement. So exactly here the angle is there, and here it is water tightness is provided, so air cannot enter inside. So generally for the soft soil, so very sharp, you can say soft soil है होगा एकदम sharp point हम provide कर सकते हैं, easily it will strike into the soil, and also used for the pneumatic caisson. So what are the advantage if you are going to use this cutting edge with the sharp end? So sinking can be done without excavation अंडर कटिंग एज के नीचे एक्सकेवेशन करने की जरूरत नहीं होगी, क्योंकि बहुत ही शार्प है. ऑटोमेटिकली द एक्सकेवेशन कैन बी डन विद द हेल्प ऑफ दैट शार्प एज ओनली. इट प्रिवेंट्स एयर इन केस ऑफ न्यूमेटिक केसन, बिकॉज यहाँ पे that extended portion, that sharpness, that is helping in avoiding entry of water or in case of pneumatic caisson, it also prevents air. But what are the disadvantage? If one side of the caisson strikes on soft strata, एक बाजू soft strata आ गया, दूसरी बाजू थोड़ा hard strata आ गया, so in that case what will happen? The tilting may be possible. एक side ज़्यादा वो sink हो जाएगा, दूसरी side वो ऊपर रह जाएगा. So it does not provide enough bearing to other, because one side it is soft, second side it is hard. So unequal sinking may be possible. Also, it can get twisted or damaged if any obstructions such as boulders. अगर बड़े बड़े boulders आ जाता है नीचे और ये sharp edge है, तो then there are chances that it may be damaged, or in certain cases it may be twisted, twist हो जाए या damage हो जाए. So there are certain advantage and disadvantage of this cutting edge with sharp end. Now next is cutting edge with blunt end. So here this blunt end means it's not exactly sharp as यहाँ पे जैसे initially था sharp end था, यहाँ पे आपका base flat है. So in all the cases you can see it's having the base which is flat one. Okay. So for the average condition of soil or specialized condition नहीं है, you can utilize this kind of blunt end kind of cutting edges. Now here this is particularly having more angles. You can see more angles are there, and that is used for the rocky stratum, because rocky strata है तो it's very difficult cutting edge को अंदर डालना, sinking करवाना, the whole thing is very difficult thing. So in that case proper protection and strength is essential. That's why this kind of arrangement may be provided, and this is used when it is to be built from land से ही पूरा आपका caisson बना के जाते हैं. तो this precast पूरा concreting करके this kind of cutting edge may be used, but all are with the blunt end. So there are also certain advantages and disadvantages of both the types of cutting edges. If it is blunt end, what are the advantage? Bearing area is more. पीछे इसका जो bearing area है that is more as compared to sharp. Sharp में तो सिर्फ एक straight line में भी there. It does not twisted or damaged easily. जल्दी twist या damage नहीं होगा as compared to sharp end. But what are disadvantage? Thing is that you have to do necessary excavation under the cutting edge. It is compulsory that, because it will not strike automatically on the soil, because it is having blunt end or it's a flat at the bottom. So excavation is essential. In that case of sharp end, अगर आपने excavation नहीं किया तो भी वो अपने आप थोड़ा excavate करके the sinking may be going on. But here it is necessary to go for the excavation under the cutting edge. Then not much effective in preventing the escape of air. प्रॉपर एयर टाइट नहीं होता है, बिकॉज यहाँ पे ब्लंट एंड है, देयर इज नो एयर टाइटनेस इज ऑब्जर्व. सो जनरली this kind of a blunt end that cannot be utilized in case of pneumatic caisson, because absolute water tightness is required in case of pneumatic caisson. So these are two types of cutting edges. Many times in exam these cutting edges are asked, so in that case you have to explain each and everything. Okay. Now what are the factors that you have to consider before choosing any type of cutting edge? So these are the factors to be considered. Definitely the nature of soil, कौन सी soil है, that is very essential. Soft soil, hard soil, boulders ज़्यादा है, किस type का arrangement है. So that nature of soil through which the caisson is to sunk, then that you have to see. Next is method of sinking, कौन सी method से sinking करवा रहे हैं. Then method of construction, कौन सा type का आपका caisson है. Okay, water tightness is required or not, that you have to see. The nature of ultimate soil stratum, exactly at what point it has to reach. Okay, so that is called as the ultimate soil stratum on which the cutting edge to rest while the concrete is being placed. Bottom plug हम जो provide करते हैं वहाँ पे exactly कैसा soil का nature है. So depending upon that you can choose any type of cutting edges. Now we have learned floating of caisson, float कैसे करवाते हैं, अभी cutting edge के बारे में पढ़ा. अभी हमको exactly sinking of caisson. So it's very essential that you have to allow this caisson to sunk in water, and there are various methods available for that. So these are the methods to facilitate the सिंकिंग ऑफ केजन. केजन को पानी के अंदर उतारना और उसके एग्जैक्टली जो बेड लेवल जहाँ पे हमने डिसाइड किया है वहाँ पे उसको पहुँचाना, दैट इज कॉल्ड एज सिंकिंग ऑफ केजन. सो दीज आर 4 methods that are generally adopted. So first one, that is air and water jets. So jets are generally provided with the cutting edges. जैसे मैंने बोला स्प्रे नोजल्स प्रोवाइड करते हैं, so just to reduce this skin friction between the surrounding soil and the caisson. So by air and water jet continuously, it is allowing it to sink in the water. Next is blasting. Actually, blasting is a very dangerous kind of thing. So, but if it is required, अगर कोई और possibilities नहीं है, तो you can go for the blast. So, explosives such as gelignite that are also used with the cutting gauges and used to remove the obstructions such as rock and boulders, etc. So, excessively जहाँ पे rocks and boulders अगर soil strata में है, so in that case it's very difficult. Sinking process is very difficult. बहुत सारा load लगा देंगे तो भी नहीं होगा. So in that case you have to go for the explosions using these explosives, but very carefully you have to do this kind of thing, otherwise it may damage your cutting gauge, etc. Next is loading. So this is the usual method as I have discussed कि भाई loading apply कर दो. So this is very simple method. From the top you have to apply load. Next is sand island or artificial island. So this you should try to understand. It's somewhat different. So this is what figure of loading of a well. So it's a well foundation. So here you can see these rails, then I sections are there. Above that the timber planks are there, and above that sandbags. So just to apply the load, to apply the sinking of caisson. Now we'll discuss the method, specialized method, and that is called as sand island or artificial island. इसका मतलब ये होता है कि पानी के अंदर हमने एक सैंड का आइलैंड बना दिया है, and then through that sand island we have to allow our caisson to sink. So just try to understand this. This is our water level. ठीक है, ये water level है अपना, and this is the bed level. Okay, at somewhat level you have to reach your particular bottom of the well. So here I am talking about this well foundation. Okay, so initially what we are doing, we have to make artificial island of sand. So it's a complete sandy strata now. It's not the soil. We are just allowing all this sand strata artificially we are adding. Okay, so and now then after we will allow our original caisson to pass through this sand island, and then continuous sinking is to be done. Okay, so I will explain you this method. So here the whole method, how to do this or how to create this sand island. So basically the height of the sand island here, so you can see the water surface. The height of this sand island, it is above water surface. So water surface से ऊपर तक sand island होगा, and then after in the remaining spaces, this is the river bed level, and this is the hard strata up to which we have to apply our bottom of the caisson. तो इनिशियली आपको क्या करना है, आपको ये करना है कि आपको एक आर्टिफिशियल सैंड आइलैंड बनाना है, ठीक है, एंड इट्स हाइट शुड बी मोर देन द हाइट ऑफ दिस वाटर लेवल. तो इसके लिए टिम्बर फॉल्स वर्क एक्सेट्रा दैट इज टू बी कैरिड आउट, टिम्बर का काम वगैरह करना पड़ेगा टू अप्लाई दिस. सो हाउ विल यू क्रिएट दिस? Okay, so that is what I am going to explain this now. Okay, so where you have to adopt this kind of thing? So you have to adopt this sand island method when subsoil conditions are such that subsoil condition ऐसी है it is not possible to keep the caisson stable रह ही नहीं सकता. So you have to adopt this because this is the expensive method. So in specialized condition only you have to use the sinking of cylinder and filled it with the sand or other dredge material. मतलब एक स्टील का सिलेंडर लेना है, उसको सैंड से भरना है या अदर जो भी ड्रेज्ड मटेरियल, एक्सकेवेशन से जो भी मटेरियल निकलता है दैट इज कॉल्ड एज द ड्रेज मटेरियल, उसको अंदर भर के आपको एक सैंड का आइलैंड बनना है. सो इनिशियली प्रोसीजर, इफ यू जस्ट सी द प्रोसीजर, मैट्रेस इज मेड अप ऑफ लूजली वूवन टिम्बर का जो मैट्रेस आता है इट शुड बी, सो हियर एट दिस लेवल इनिशियली ये जो आपका बेड लेवल है यहाँ पे आपको मैट्रेस डाल देना. ठीक है, इनिशियली ये पूरा एक बेड लेवल ही है, ये जो सिंकिंग हो चुका है दैट इज नॉट दैट, इट इज जस्ट द मैट्रेस. एक मैट्रेस को डाल दिया, ठीक है. देन टिम्बर फॉल्स वर्क इज कंस्ट्रक्टेड अराउंड द पोजीशन ऑफ सैंड आइलैंड, जहाँ पे सैंड आइलैंड क्रिएट करना है उसके आजू बाजू टिम्बर फॉल्स वर्क. देन स्टील शेल इज लोवर्ड, जैसे स्टील का सिलेंडर. सो यू हैव टू अप्लाई, दिस इज द स्टील शेल, ये जो आउटर है ना ये स्टील का शेल है, स्टील का एक सिलेंडर अंदर डाल दो. तो व्हाट विल हैपन, ये जो मैट्रेस वाला पोर्शन है उसको वो कट मीन्स उसके ऊपर जाके रेस्ट कर जाएगा. So this steel shell, it will just rest on the mattress. एक मैट्रेस आपने जैसे सपोज बेड लेवल पे लगा दिया, उसके ऊपर आपने स्टील का सिलेंडर डाला, अब आपको क्या करना है, वो मैट्रेस को हटाना है. So for that what you will do, when the steel shell reaches the mattress level, a sharpened pile is moved into that and it will cut the mattress. So पूरा का पूरा mattress आपका cut हो जाएगा and it is removed from the shell and you have to take out that mattress from the shell. अभी ये open हो गया, ठीक है. Now inside of the shell is then filled with the sand or dredged material, and with that, within that shell you are just filling all the sand and all the dredged material, so that will increase the level. The pura shell with the sand, it is completely filled up. ये पूरा sand से भर दिया आपने, everything it is filled with the sand. So this level that you have to achieve above water level. So पूरा एक sand का island बन गया like this. Now you have to start sinking your well within this sand island. Sand island से अंदर डालना है आपका caisson. So construction of caisson is commenced and sinking of caisson is effected under its own weight and by dredging out inside surface. Which जैसे suppose ये जाना शुरू हुआ initially, तो initially there is a sand, तो वो sand को आपको बाहर निकालना है and you have to just allow it to sink through this sand level and you have to allow it to sink in, and that is with the help of the additional load. When caisson reaches the desired depth, the seal, you have to seal at bottom and top. So top seal and bottom plug, that is to be done. And the filling is dredged out and the steel shell is recovered for the reuse. Once it is reached to this particular level, bottom plug, upper cap, that is to be provided. Then after you have to take out this shell, to be dredged material sand here, that you have to take out. So what it is giving protection, because here there is a water level, but it will not allow it to come in contact with the water level. That is the meaning. Okay, exact water के contact में नहीं आएगा because surrounding sand island है. उस sand island में से आपको आपका caisson sink करवाना है. So this artificial island that we are creating with the help of sand, that's why it is called as the sand island method or artificial island method. So what are the advantages? Chances of sand blowing under cutting edge is reduced. Sometimes क्या होता है, अगर soil ऐसा हो, बहुत सारा sand blow करना start कर जाता है at the cutting edge, so it will not happen. Then steel shell is carried out above the highest flood level. Hence work cannot be affected during flood also. पानी का कोई effect नहीं होगा because already we have to allow our caisson to sink through sand layer, not water layer. So highest flood level से भी ऊपर का level होता है of steel shell, so you can work during floods also. Then alignment of the caisson during sinking can be properly controlled. आपको पता है आपको sand layer से नीचे जाना, and the construction work is easily accessible and it is done under dry conditions. So पानी का इतना कोई contact नहीं रहता है, as it is as you see in other, कि directly पानी में sink नहीं करवाना है. We have to allow our caisson to sink through the sand island. That is the important thing. But disadvantage, as I have told you, it's very expensive. It is expensive but very effective. In case where the sinking of caisson directly into the soil cannot be done successfully. So where such conditions are there, it is very difficult to go for the sinking, and in that case this effective and expensive method can be adopted. So only thing is that water की जगह हमको sand के island में से अपना caisson pass करके sink करवा के उसकी position पे रख देना है. That is the only thing. Now what are the troubles? When, because this sinking to be done through water normally, because it is mostly used in underwater construction, so many troubles might be there. So these are the four major troubles that will just encounter during sinking of your well or caisson. And first one is skin friction. So घर्षण बढ़ जाए, आप गुजराती में कहिए, ये तो always it is there. So this is very common factor. Second is sand blowing. So sand blowing means surrounding soil. If you are just doing sinking and at the same time some water is entering, so dewatering is going on, and during dewatering surrounding sand, if it is a sandy strata, then so many sand is going to come inside your caisson. Caisson ની અંદર generally it is there, it's a well caisson માં generally आई सके because it's open from bottom. In box caisson this kind of trouble may not be there. So sand may blow and that may come inside your caisson. Then tilting of caisson. So it may tilt from one side if unequal dredging is there, or one end there is a soft strata, another end there is a hard strata. So unequal dredging, etc., that may result in tilting. So here you can see આ એક બાજુથી સપોર્ટ આપીને એને ટિલ્ટિંગને રોકવાની ટ્રાય કરે છે, ટિલ્ટ ના થઈ જાય એક બાજુ વધારે. Next is shifting. The horizontal direction માં આખું shift થઈ જાય આખું. So that is called as shifting of valve. So normally open caisson જ્યારે use કરતા હોય, this kind of sinking problems may be coming up. So skin friction. So basically skin friction is very simple. Additional load that a caisson can carry due to sinking friction. Skin friction. Okay. So this skin friction, it is nothing but simple ઘર્ષણ બળ જેને આપણે ગુજરાતીમાં કહીએ. Okay. Next is sand blowing. So this sand blowing, when the caisson is passing through the sandy strata during the process of dewatering, after dewatering કરી રહ્યા છે અને sandy strata છે, so the ground around the well starts breaking up. The whole area around your caisson wall, that is now starting breaking up, and wide cracks are seen in that. And the sudden fall of sand in the caisson ની અંદર sand આવવા માટે. And in certain cases, as much as 3 to 15 meter of sand, it may also come up inside your caisson, and it may result in serious accidents. So in that condition, what you should do? Dewatering should be stopped. If you are going dewatering कर रहे हैं पानी निकालने का काम, so it should be immediately stopped, and bundle of grass or other such certain material that should be placed all around the staining. जो भी अपना वो जो staining होता है ना main part, उसके all around you have to provide, just to avoid the sand blowing. Next is tilting. So you can see in this figure पूरा का पूरा एक side से tilt हो चुका है. Okay, vertically पूरा one side. So at the time of sinking process, caisson should sink vertically downward in a straight direction at the corner position without any tilting of the caisson. That is the essential requirement. But what will happen if caisson sinks more on one side? इस तरफ से तो ज़्यादा sinking हो गया है और ये तो ऊंचा रह गया क्योंकि यहाँ पे sinking कम हुआ. While sinking in operation, then it is called as tilting of caisson. एक side ऊंचा, एक side नीचा. So that is tilt position. All of you are knowing this. So when well is sloped against vertical alignment से कुछ तो angle है इसका. Okay, so horizontal, with that this vertical alignment is making certain slope, then it is called as tilting of caisson. So normal reason is that unequal dredging, excavation proper नहीं हुआ है at the cutting edge side. नॉन यूनिफॉर्म बेरिंग पावर ऑफ द सॉइल, जैसे मैंने बोला नॉन यूनिफॉर्म बेरिंग पावर मीन्स एक सॉफ्ट सॉइल है उसका बेरिंग कैपेसिटी अलग है, हार्ड सॉइल है उसका अलग है. सो इन दैट केस ऑल्सो द अनइक्वल बेरिंग पावर that will also result in tilting of caisson. So this should not happen. Okay, so there are certain precautions that should be taken to avoid the tilting of caisson. So what are the remedial measures to bring a tilted well in a position? कोई भी well अगर tilt हो गया है तो उसको original position में लाने के लिए क्या करेंगे? तो there are various methods for that. So first is pulling the tilted well को खींचना है. So here you can see this this is the tilted well. You can say आपको जैसे दिखेगा this is the tilted caisson. ये already tilt हो चुका है, and here there is a already constructed caisson without tilting, and here you can see this pier portion. Now what you have to do in this method, the tilted caisson is fixed with an already constructed caisson. With the help of cable and hook, you have to fix it with this. Okay. Now a ring beam is provided at the top of tilted caisson. तो पूरे tilted caisson के around एक ring beam provide कर देंगे, and that is to be connected with the cable and try to pull it. इसको खींचने की try करें. Okay. By hook and cable arrangement, a pull is applied by tackle and winch gear, which brings the tilted caisson in vertical position. So just simple by pulling method, you can do this kind of thing. But here this is only possible कि वो आपके perpendicular direction में, but parallel direction में तो हुआ तो. So if a caisson is tilted in direction perpendicular to the line of joining, it is in the existing caisson. उसकी line में ही है वो. Then in that case, pulling machinery is to be brought. Pulling machinery से काम करना पड़ेगा आपको. Okay. So in which direction, अगर side का है, कौन से direction में वो tilt हुआ है, then which direction you have to bring it, depending upon watching that direction, perpendicular है, parallel है, किस direction में tilt हुआ है. Accordingly, you have to use the existing caisson, or otherwise you have to bring the pulling machinery to fix this tilt. Next is controlled dredging. So dredging is done only near the portion which has tilted. यहाँ पे tilt हो चुका है, वहाँ पे आप थोड़ा control dredging करो. And portion which is higher than other is termed as tilted. ये तो आपको पता है कि कौन सा higher position है. So extreme care is to be taken. Otherwise क्या होगा? If extremely dredging if you are doing, जो हायर पोर्शन है वहाँ पे आप करके उसको नीचे लाने का ट्राई करो, तो अदरवाइज टर्निंग में भी पॉसिबल पूरा का पूरा वो टर्न हो जाए. So that should not happen. So extreme care is required when you are doing dredging on one side, which is tilted higher. Next is eccentric loading. So heavy load are placed on the tilted edge. So here you can see this is the tilted edge. Tilted edge है, उसके ऊपर reverse direction में heavy load apply करो. So that will try to compensate this tilting. So the moment caused by the heavy loads bring the well in the true position. Now the next method is pushing by the jack with the help of hydraulic jack. यहाँ पे jack provide कर दो. So this is your tilted well. So this tilted well is to be provided in this direction now. If you want to bring it in a vertical position, so with the help of hydraulic jack, the push can be applied. Push करो इसको इस डायरेक्शन में and try to recover the tilted position, and it can be brought back to its original position verticality. Then use of explosives. So here it is also risky method, as I told you, जैसे पहले भी हमने बात किया था. So this is basically used for the remedy purpose, not for the sinking purpose. So in this method, the explosives are used to remove the obstacles from the tilted edge. If some obstacles are there, if you find that some obstacles are there tilted edge में, so try to remove it with the help of explosives. This blow created by the explosive removes any obstacle under the tilted edge. इसके अंदर कुछ हो गया है तो वो सब कोई भी आपका obstruction निकाल देगा. But it is also a risky method and hence to be adopted only under exceptional cases. अगर दूसरा कोई method आपको proper नहीं लग रहा है और feasible नहीं लग रहा है, in that case only these explosives are to be used. Next is water jetting. So just you have to pass the water jet pipeline. So in this method, water jet is forced on the outer face of the well towards the higher side. यहाँ पे higher side आ गया, वहाँ पे पानी allow करो. So that will reduce the friction. Friction remove करेगा towards the higher side, and generally it is useful when this tilting of well has taken place in the sandy strata. So वो lose कर देगा strata को, and automatically जो rise वाला portion है it will come out at the original position. But this method is not that much effective, but it gives the better result if you are combining with the other method. All alone this method cannot be that much effective कि भाई water pressure डाल के आपने कर दिया. Along with this water jetting, some excavation has to be done. Then providing temporary obstacle below the cutting edge. So here below the cutting edge you can provide certain obstacles, like this is wooden sleeper. जो नॉर्मली रेलवे में प्रोवाइड किया जाता है, वो वुडन के स्लीपर बहुत सारे आप यहाँ पे डाल सकते हैं. ठीक है, अगर एक्सेसिवली इट इज टिल्टेड इन दिस डायरेक्शन, तो दैट विल मूव इट इन अपर डायरेक्शन. सो इन दिस मेथड sinking on the lower side is artificially arrested by the inserting hard wooden blocks. These sizes are given. So 4 to 5 such plates, steel plates or wooden sleeper that you can provide at the base, and then sinking operation is continued on the other side. इसको आपने ऊंचा कर दिया, दूसरे साइड पे आप अपना कंटिन्यू रखो, and this tilt can be rectified. And once it is rectified, you have to remove this block. So simple method you have to just apply to rectify your tilting of the caisson. Now deposition of earth on one side. एक पे आप deposit करो and second पे excavate करो on the other side. So here you can see this is the tilting position. तो ये tilt को आपको इस direction में लेके जाना, ठीक है. So to do that, here we have to apply excavation. यहाँ पे excavation करो and यहाँ पे filling करो, and at the same time you pull it in this direction. So by excavating on one side and filling the portion which has already tilted in one another side, that will bring back it to the original position. So by this operation, the earth pressure on the higher side is released and the lower side increased due to and due to that you can correct the tilt. So very simple method, એક બાજુ earth નાખવાની, બીજી બાજુ earth ને remove કરવાનો. So that will automatically take out in the original position. Now the last is which is called as shifting of caisson. So up till now whatever we have discussed is tilting. So tilting means vertically it is having certain slope, but whenever we are calling shifting, so shift is in horizontal direction, આખું ને આખું shift થઈ જાય. Okay, so this shifting is different from tilting. So vertically it is same, but horizontally it is moving. So this is the total shift at the base, આખું ને આખું base તમારું હલી જાય. So during sinking operation it may also shift from its original position. At the place where we have kept our base, it will just shift in a horizontal direction. So when well is moved away horizontally from the desired position, it is called as shifting of the well foundation. And if shifting, agar shifting થઈ જાય horizontal, there are many piers. Okay, બહુ બધા piers હોય in the bridge. So it's a big span bridge, so many piers are there, and below piers you are having caisson. So what will happen, just try to understand. Agar horizontally shift થઈ જાય છે, તો that will reduce its span length. બે pier વચ્ચેની ઓછી થઈ જાય, અને બાકીના જેની બાજુએ shift થાય એ બાજુની એની span length ઓછી થઈ જાય, અને એક બાજુ વધી જાય. Because suppose 5 piers are there, and third one it has shifted, so it will affect second one as well as fourth one. So if it has shifted towards second one, then the span length between second and third it will be reduced, and from the span length between the third and fourth, that will be more. So this will all affect its span length. That is span length જે હોય બે pier વચ્ચેની, that will be affected, or the bay caisson વચ્ચેની you can say. And hence it is eccentric loading on staining and foundation is possible. So load whatever for which it is designed, it will be affected. And eccentric loading condition, unequal loading condition, that will be possible. So hence it is very essential that proper precautions are to be taken, so that there should not be any tilting of caisson, or there should not be any shifting of caisson, because ultimately above which normally in underwater construction for the bridges we are using caisson. So that will affect the whole stability of the bridges by affecting the stability of the piers on that. So this tilt and shift again, just to revise quickly, this tilt and shift, they are deviation of the well from its original position and orientation. So generally it is seen that the maximum allowable tilt is 1 in 80, means 80 ની લેન્થ હોય તમારી ઉપરની હાઈટ, તો એના અંદર only 1 meter તમે vertically tilt is allowed. And maximum shift, that is 150 mm, means original position થી આટલું 150 mm એ shift થાય, that is allowable, not more than that. So always they have to check this tilt and shift of caisson. So what are the causes? Causes are very simple. Eccentric dredging unequal થાય છે, then it is possible. Then it may cause due to boulders under one side, excessive boulders આવી જાય, obstruction આવી જાય, so that may also cause the tilt and shift. So now we are talking both in conjunction. So what are the measures to avoid this tilt and shift? So generally, as I told you, that this is happening in case of the well foundation. So we already I have explained this well foundation, so just to revise that, because some people they may not be present or whatever, just to revise that. So these are the components of the well foundation. At the bottom it is provided with cutting edge. Now it has the curve portion, okay, and above curve this is the main portion, that is called as staining. And this is bottom plug, and this is sand filling or any other dredge material, you can fill it. This is top plug, then after this is the well cap, and this is the original pier position. So what are the precautions to be taken if you want to avoid the shifting and tilting of caisson? So now you have to follow this. The outer surface of staining and curb, it should be kept as smooth as possible. ये जो curb का portion है और ये staining का portion है, it should be smooth as far as possible. Then radius of the curve, it should be kept 2 to 4 centimeter larger than the outer radius of the well staining. जो कर्व पोर्शन है ना, उसका जो रेडियस होगा ये स्टेनिंग से थोड़ा सा ज़्यादा रखना है. Then the cutting edge of the curve should be uniform in thickness. कटिंग एज का साइज डिफरेंट नहीं होना चाहिए. इट शुड बी यूनिफॉर्म इन थिकनेस एंड इट शुड बी शार्प एज फार एज पॉसिबल. एंड ड्रेजिंग, जो भी हम एक्सकेवेशन करते हैं, ड्रेजिंग शुड बी डन ऑन ऑल साइड of well uniformly, because this unequal dredging is the main reason, and apart from any obstruction which is meeting in the excavation, while excavating or while sinking of caisson. So this kind of precautions are to be taken while uh, you are designing a well foundation. So these are the components of well that you are knowing. Now methods of checking tilt and shift. कितना tilt हुआ है, कितना shift हुआ है, that you can check with the simple method. So this calculation can be done with the help of level and total station. So more specifically, that precise level, dumpy level, you have studied in your first year. That level that can be utilized to find out the level difference, and either you can utilize total station. So simple method is adopted. In this method, suppose this is the well, okay, this is the diameter, and markings are given 1, 3, 2, and 4. Now what you have to do, you have to check the difference of level in the height of points between 1 and 3. 1 and 3 उसका लेवल चेक करो, ठीक है. सो एग्जैक्टली अगर कुछ भी नहीं हुआ है, आपका सेम है, तो इट्स ओके. बट इफ देयर इज सर्टेन लेवल डिफरेंस, then you have to note down this level difference between 1 and 3 position. So definitely you might be knowing if certain deviation is there in the position of 1 and 3. So that level difference you have to find out. So what the tilt may be taken as RL of 1 minus RL of 3 divided by that much the diameter of your well. So when you divide, so that will give you the tilt which is there in your particular well. And shift, for shift at the bottom, from the top position, top six, because basically shift is what? It is exactly shifting your position, bottom position from the top position. टॉप से आपका बॉटम पोजीशन हिल गया है, ठीक है. सो दैट कैन बी ऑब्टेन्ड बाय फाइंडिंग आउट द टिल्ट डिवाइडेड बाय द लेंथ ऑफ योर केजन. सो दिस प्रोसेस कैन बी रिपीटेड 1 and 3 पे किया. सिमिलर वे यू कैन डू दैट प्रोसीजर at 2 and 4, and similar manner you can find out the tilt, and then you can calculate combined tilt and shift. And based on this combined tilt and shift, the remedy that can be adopted to bring it to the original position. So here at the end, I have just put one complete bridge pier with all the components just to revise everything. So this is nothing but this is the well foundation. So at the bottom you can see this is well foundation with all the components I have explained: cutting edge, curve, staining, top plug, and well kit. Above that you are having the piers. So this is called as substructure basically. So that this is the pier that you can see when you are traveling through this any bridges. So this pier, above that you are having the complete superstructure, that is again consisting of the girders and then deck slab and with your handrails etc. that is provided. So this is the path on which you are moving. Okay, so this is the complete structural part of bridge pier along with the caisson foundation. So with this, thank you very much all of you, and I am now ending this presentation.